Hi, I'm Dave here. Today I got a very odd and interesting bit of equipment. This is a Laben Spectrascope Modular 8000. And when you see 1000, it's gonna be good. Laben was actually stand for Nuclear and Electronics Lab. It was actually in Milan, Italy. So yeah, it's an Italian kind of odd instrument. So Laben was actually then acquired by is now actually acquired by Alenia Space, which is a space company. But back then, actually, they made very old kind of instruments like this and other kind of instruments related also to space. I would have actually preferred some instruments related to a space kind of program, but I got this thing. This thing was actually trashed, and I decided to pick it up because it's so cool. Oh, look at those knobs. I mean, tens of controls. I mean, Jesus. So, from what I know, this very instrument was used in a nuclear medicine lab, and I really don't know what was its use specifically, but I found some paper online and that talk about this instrument being used in DNA fragments, for analyzing DNA fragments, and for counting and analyzing small particles. So what this is at least it should be a multi-channel spectrum analyzer, but it's not your regular spectrum analyzer what you find in a electronics lab. It's a very specific instrument for very specific applications. So as I said, I found this thing trashed and I decided to pick it up, and now I really don't know what to do with it. It's very interesting, actually, bit of equipment, but geez, it's actually taking a lot of space. It's a very big instrument, and it's very heavy too. It's about 45 kilograms, something like that. It's very bulky. It's all made of steel, and I don't know. I never tried to power it up. If I can power it up, see if I can actually make it do something at all. I mean I couldn't find any information about this in the internet. I mean no manuals, no user manuals, no service manuals at all. So I really don't know how this thing works, and I really don't know what most of the knobs and controls do. Over here you have a lot of knobs and controls. On the top you have operation control, and basically those are actually modules that I think you can possibly go and take out. This is a modular kind of instrument. So here you have a computer operation mode, which is interesting because this means that there is a kind of a very early computer inside, and you have those really quite nice multi-turn knobs. And right on the bottom here you have some memory kind of functions. I think you can actually memorize and save some spectrum. This is the memory size. I don't know. Channel selection, you have those very nice thumb wheel selectors here. On the bottom here you have timing control, measure time, periodic. Over here there's a whole space for other modules that now you see empty, but I actually do have the the panels here, the cover panels, and a full module. This big thing here, it's a ADC. Look at that. And that went right there, somewhere here. So yeah, but those seem to be standard NIM modules, and by the looks of it, you can see right here on the bottom, I don't know if you can see it, but there is the power kind of supply input, and you have your data on this very expensive amp connector. You see, actually those are very rare to find, and very expensive actually. You have a kind of a serial interface, kind of RS-2032, I don't know. But anyways, and it's nice how they actually managed to label everything with those little beads, and everything is just labeled. Yeah, but there are no other connections here, so just one single module. Oh, I don't know. Alright, so let's see the back. You have a bunch of connectors, BNC's connectors, and you have some banana jacks, and also those huge multi-pin connectors here. And what's actually interesting is that they use actually XLRs for mains input and output, which is kind of you know, kind of odd, but I guess it's okay. Alright, so I found a label here. You can see Laben, Milano, Italia. There is a model number, Spectrascope Modular 8000, and this is the serial number. And I think 108 is the real number of units they have produced till this one. Alright, so let's try to power it up. I have my big isolation transformer right there, and it's plugged into the back, and I have also a little ground lead coming off, and let's try to see if this thing works. Finger crossed. Oh, we have some life, at least. We have some lights turning on, and let me. Oh, we have a trace. Oh, there we go. We have something. And is this? Oh yes, it kind of works. Let's see if I can. Oh yeah, can move the trace up and down. Yeah. Wow. And it's actually quite sharp. Yeah, let's make it sharper. Astigmatism. There we go. Wow, let's see the display. Oh, also the display will have something. What is T? I don't know what's going on here. So I'm desperately trying to do something with it, and you know, I tried to put a signal through it, a 1 megahertz signal, a 10 kilohertz signal, even a low level signal in, but no, there's nothing going on here on the screen. And this is an ADC, so it should convert the analog here signal to a digital signal that's gonna be interpreted by the computer mode and perhaps show something, but nope, there's nothing on the screen. It does absolutely nothing. So, oh my god. Yeah, let's try and open up the back here and see we have all the voltages present. So here you have your power splice, huge. There are two huge transformers. This is the actual CRT power supply. See the main fuse. Wow, it's hot. Wow, it's very hot. But it seems alright. There's the 5 volt fuse, and I think it's a 15 amps, something like that. Yes, it's a 15 amps fuse. Alright, so let's test this. Let me turn it on. There we go. And this is the ground, so let's attach it there. So it's so nice how they actually provided all these those kind of test points. So this should be 36 volts, and it's yes, kind of there. 24, yeah, plus 15, yeah, plus 12, oh yeah, plus 5. Yeah, it's perfect. Minus 24. Yeah, minus 12. Yes, it's a little bit low, but you know, minus 14. Jeez, it's more than 2 volts lower than it should be. So there might be something wrong here. Perhaps a something disconnected. I don't know. Because it's perhaps it's not properly loaded up, and so it's a little bit lower. I don't know. It's minus 6. It's alright. Interestingly, there is a 220 volts wire going into the actual module here, and the fan is not happy at all. Yes, I came to a point where I tried almost everything to display something. Yeah, I really don't know what's going on here. I really want to try something. I want to try and remove this module, which is the display module. Let's see if I can. First, so here. So this right here. And this should just slide out. And you can your back. Which is so now, okay, slide out. There we go. That's, oh man. Oh man. Alright, look at this mess. This is a little bit of advancement here. So I figured out how to make this thing work. This is the CRT section. I cleaned it up, and now it's actually powered up by a lot of power supplies. Here are the low voltage power supply for the amplifier board, and they are actually using some Motorola MC 1520Gs right there, and yeah, for the operational amplifier here for the first stage, and the final stage are using 2N3439s from RCA. Really quite nice board. So as I said, I'm running this thing from a lot of power supplies, and those are the 3 low voltage ones, and have a high voltage one for the CRT, and the main B plus for the CRT is provided by the Variac. So it's about 3000 volts, something like that, and we have a 150 volts going in as well. And look at that, isn't that beautiful? So I connected this to the horizontal and vertical to make it an XY display, and that's working quite nicely. I kind of like it. It's very sharp and clean. I really am surprised with this CRT, and yeah, the knob is not the greatest, but yeah, there we go. It's vary the frequency here. Let's go to, so this one is set to 150, and let's go with this one to 500. Let's go a little bit, and there we go. And let's bias a little bit this one, so I'm gonna get a moving picture. So 0.1 Hertz, and there we go. You have the classic Lissajous pattern right there. But anyway, I really don't know what to do with it right now, because I really need a lot of voltages, a lot of power supply that here are not fitted. There is just the 3000 volts transformer right there, and nothing really else. I need 5 volts, which is this one, plus and minus 20 volts, and a plus 200-ish volts to run this. So yeah, I can actually transform this thing to a very nice XY CRT display, and so yeah, that's a mess to make it work, but yeah, that's really quite nice. Alright, so it's now on the bench. I tried to clean it as well as I could. Remove some parts, like this one here. This is the over intensity kind of thing, and you know, it doesn't really need it anyway, so yeah. Alright, so here's the little swinging little dot. I actually modded a little bit the light. There were actually two little light bulb for the scale illumination, and now actually turn up a little bit of blue. It seems like a submarine kind of radar, one of those ping radars. It's really cool. Alright, so this is looking really nice right now. There is a slight little problem, is that I need a lot of power supply rails to do it. So yeah, I mean, I don't really mind the +5 and plus and minus 24 volts, but it's gonna actually be difficult to have a plus 250 volts to actually run it. So yeah, I need to figure out a way to mount all those power supplies in this thing. So yeah, so this is gonna be actually the first part of the various of the teardown project of the Laben Spectrascope, and this is a really nice score right there. Alright, so hope you enjoyed. Thanks for watching, and I'll see you in part 2. Bye.